So good morning, everyone, and welcome to today's session on net zero food production. We're going to be exploring understanding the role that biotechnology can play to support the food manufacturing sector's journey towards net zero. I'm Lindsay Dunbar, and I'm one of the Senior Business Engagement Managers at the Industrial Biotechnology Innovation Centre, and I'm delighted to be chairing today's event. And I'm really looking forward to today's session. We've got some really exciting speakers lined up for you this morning. So before we start, I thought I'd give you a quick overview of the agenda for today. We'll be together for approximately 2.5 hours, and I'm going to start off with a little bit of housekeeping. I'm then going to talk around the Bioeconomy Cluster Builder project, who we are and what it is we do. And I'm also going to highlight a funding opportunity that's available exclusively for today's webinar participants. I'm then going to pass over to Simon McKeating from Food and Drink Federation Scotland to open today's event. We'll then move on to our guest speakers, and then there'll be some time for some Q&A. That'll bring today's session to a close. So a little bit of housekeeping. We're in a webinar format, so all participants will be muted for the duration of today's session. And if you have any questions for one of our speakers, please use the Q&A box. We'll move on to the Q&A segment after all of our speakers have presented. If you have any technical issues at all, please do let us know through the chat box, and our technical team will be on hand to support you. And today's webinar is being recorded, so following on from today's session, we'll make a recording of the event available on the Bioeconomy Cluster Builder website. So I'm just going to give you a quick overview to the Bioeconomy Cluster Builder project for those of you who might not have come across it before. It's a collaborative project between ourselves at the Industrial Biotechnology Innovation Centre and Innovate UK KTN, and we're here to help raise awareness of the benefits and applications of industrial biotechnology. So, for example, running things like today's event, and we connect people and resources and help develop new and existing value chains. And we encourage the utilisation of Scotland's bioresources. So, for example, ourselves at iBioIC and Zero Waste Scotland and Scottish Enterprise have mapped out Scotland's biomass availability. And iBioIC hosts a tool called the Bioresource Mapping Tool, and we can produce reports based on queries that we receive. So if this event is of interest, then please do get in touch following on from today's session. And here's an overview of the events we've had to date. In total, we've held 33 events, and the events have been across a wide range of sectors, and we've explored a variety of topics, including things like textiles and construction, so maybe some sectors you wouldn't necessarily associate with industrial biotechnology. And also we've done some support sessions, so things like on carbon accounting and life cycle analysis. And next week we're holding a session on IP audit. So if that's of interest to anyone in the audience, then please sign up through our Bioeconomy Cluster Builder website. And we've recorded all of our sessions, so if you're interested in watching any of them, I've included a link to our BCB website at the bottom of this slide. So we can offer different support through the Bioeconomy Cluster Builder project, and here's some ways that we could support you following on from today's webinar. We can develop challenge-based focus groups and roundtable discussions. And we also have access to partner organisations, networks, and technical support as well, including ourselves at Innovate UK KTN and in the Industrial Biotechnology Innovation Centre. And we can help identify feedstock supplies. So as I mentioned earlier, the bioresource mapping tool. And we can also signpost to different funding opportunities, which leads me quite nicely into my next slide, where I'm going to highlight a new funding opportunity that's available. So I'm delighted to announce that iBioIC is launching a new funding call called the Food Production Flexible Fund. And we're offering up to £10,000 of grant funding per project. And this has to be between industry and a Scottish higher education institute. And the academic does have to be based in Scotland, just because it's come through the Scottish Funding Council, our funding. But the industry partner doesn't have to be based in Scotland. And 50% of the project costs must come from industry, but that can be either cash or in-kind contributions. And the project must start by the 1st of March 2024 at the latest. And all projects must be completed and invoiced for by July 2024. And the funding is available to today's webinar participants, and the project must be both innovative and relevant to food production. So if you'd like to receive the call documentation, please do get in touch with our projects team, and I've included the project's email at the bottom of this slide, but I'll also make it available to all participants following on from today's webinar. So in conclusion, please keep an eye out for upcoming events. As I said, they're all on the Bioeconomy Cluster Builder website. And get in touch with us if you're interested in engaging with the Bioeconomy Cluster Builder project, or if you're interested in today's funding call. And you can keep up to date with what we're doing through our website and following us on LinkedIn. So I think that's enough from me this morning. So I'm now going to pass over to our wonderful guest speakers. And here's an overview of our presentations for today. This will be our running order. And we're going to kick off with Simon McKeating from Net Zero, who's a Net Zero Programme Manager at Food and Drink Federation Scotland. And he's going to give us an overview of Scotland Food and Drink Partnership Net Zero Programme. So I'll stop sharing, Simon, and I'll pass over to you to share your screen. Thank you.
Sorry, I'll struggle to unmute myself. It's only been 4 years that we've been doing these things, but anyway. Good morning. I'm delighted to be here to be involved in this Bioeconomy Cluster Builder webinar. I'm just going to run through a few slides introducing the Scotland Food and Drink Partnerships Net Zero Programme hosted by the Food and Drink Federation Scotland. It always feels like a bit of a mouthful when I introduce a programme, but just by way of explanation, the Scotland Food and Drink Partnership published a net zero commitment, which was launched at COP26 back in 2021. And this programme was established in the summer of 2022 on behalf of the Scotland Food and Drink Partnership. It serves the entire industry. We're not here solely to serve members of either Scotland Food and Drink or the Food and Drink Federation. We're here to support the entire industry. And the programme, as I said, is currently hosted by the Food and Drink Federation Scotland. The Scotland Food and Drink Partnership comprises several different organisations. Most of the main food and drink industry groups, including Dairy UK, AHDB, Scottish Agricultural Organisation Society, Salmon Scotland, Skills Development Scotland, and also the enterprise agencies. So we do cover quite a broad spectrum of the food system, and often when we talk about this programme, we talk about it being covering from cradle to delivery gate, so all the way from primary production through to point delivery. The reality is, if we're being true to our net zero and greenhouse gas protocol, it covers all the way to end of life products as well, which is relevant to this webinar. Just to put food and drink in Scotland into an economic context, currently turnover of food and drink in Scotland is worth about 16 billion. It's grown in the last 10 years by around 20%. There are around 17,500 registered enterprises in the food and drink system. Around 70% of those are primary production, so farms and aquaculture. They represent about 10% of all registered businesses in Scotland, and also critically, about 98% of them are SMEs or smaller. There are a lot of words on this slide, and I don't expect you to read all of them, but this is just to put this programme into the strategic context of, excuse me, the Scotland Food and Drink Partnership strategy that was launched at the Royal Highland Show last year, Sustaining Scotland, Supplying the World. We are part of one of 7 programmes which covers market growth, policy and regulation, supply chain security, innovation and digital technology, people and entrepreneurial skills, capital for growth, and net zero and the environment. And within that programme, Scotland Food and Drink say that they will build on the efforts already taken to maintain the high environmental standards in this country, and ensuring that we meet targets by addressing challenges and opportunities offered throughout the food and drink supply chain. And then to put the net zero program into context as part of overall sustainability, this is something we've been looking at recently. I mean, net zero by definition tends to be focused on scope 1, 2, and 3 emissions, but also carbon capture and sequestration. But we can't ignore the wider context of sustainability. And these are the areas that we propose that we'll also be focusing on in the Scotland Food and Drink Partnership going forward, which are around natural capital and nature restoration, so protecting and restoring the ecosystem services that we rely on, responsible sourcing of commodities, reducing the environmental impact of ingredients that we bring into the supply chains. Food waste, we're calling out as a separate pillar, and we never get away from packaging. When the net zero commitment was first published, there were 5 long-term commitments that were highlighted, which are on the screen, which are about putting net zero at the heart of sector strategies, using data to drive activity, supporting Scotland's food and businesses on the net zero journey, making our net zero transition a just one, and tackling shared challenges through collaboration. So when the programme was established, we realised very early on that we needed to put in place some governance and structure, and currently this is broadly what it looks like. So our sponsoring group is Scotland Food and Drink Partnership Board. Then, to use some programme manager geeky terminology, the senior responsible owner is currently David Thompson from the Food and Drink Federation. We have a very small team managing the programme director, myself, programme manager, and Shona, our communication and engagement manager. We established a programme board, which includes Scotland Food and Drink, Food and Drink Federation, Scottish Government, Quality Meat Scotland, and SAOS. We are setting up an external advisory group to ensure that we receive independent advice and bring in some diversity of thought. And we have established a delivery group and a technical working group. Those are maturing quite nicely. And the delivery group, we've already had a couple of spin-off groups from that, where we're looking at electricity grid connection and capacity challenges. And also we have established an enteric fermentation working group, looking at one of the biggest challenges that we have in greenhouse gas emissions in the food supply chain. Since the programme was established, we've interacted with many organisations and individuals. We've presented at, well, the nearly 30 conferences now. We held a Scope 3 workshop. Scope 3 is an area that we particularly want to focus on, and we had quite a successful workshop with a wholesale organisation with some very big companies attending. We have provided direct support to some selected businesses. Funds are limited, and we focus support on those areas where we feel that we will get most benefit in terms of case studies and publicity. And we had a collaborative refrigeration project with Opportunity North East, where we established some clear steps to identify that were identified to reduce emissions around refrigeration. In terms of priorities going forward, one of the areas that through interaction with businesses that's become very clear is that there's a need for sector-specific carbon literacy training. We've got a project starting tomorrow, in fact, with the Future Food Movement, and actually got a couple of spare places. So if anybody's interested in taking part in the Carbon Literacy Accelerator Programme, please get in touch. Better do it today because it starts tomorrow. But yeah, seriously, get in touch because we do have a couple of spare places. We are evaluating the effectiveness of this training, and we're looking at some other training as well, so that we can make recommendations to the wider food system about what's appropriate for their business. As I mentioned, Scope 3 is also a key priority for us. Scope 3 workshop we ran proved very effective. We're now developing a toolkit to enable delivery of trainer sessions for Scope 3 workshops, and we'll be working with SAOS and Scottish Bakers on that. Another priority is around access to business support and what's actually required for business. It's become clear that it can be difficult to access support. Many of the funds that are available are here today, gone tomorrow. We're conducting some research with businesses, a two-phase approach where we're doing some qualitative research with around a dozen businesses to identify barriers and challenges, and then undertake some quantitative research to provide some analysis as to what's actually needed to support businesses in developing their net zero transition plans. We hope that report will be available in April. Another key priority for us is understanding where we are as a system in terms of emissions. We're working closely with Safari on producing a visualization of data to map Scotland's food and drink industry's carbon footprint. Again, this will help us to identify gaps and further develop sector-specific mapping. So in summary, in terms of current activity and proposed activities, we have the carbon literacy pilots, we're developing Scope 3, the qual and quant research, data visualization. We're also proposing, should we have funds available, to launch a Scope 3 challenge fund next year and develop a mechanism for businesses to navigate, support landscape for net zero, potentially develop some food and drink focus tools for plotting Scope 1 and 2 trajectories and Scope 3 materiality assessment. And all the time, part of our role is also to develop subsector net zero narratives, particularly if those sectors that have some challenges. I'm thinking of, for example, products of animal origin. We have tried to describe the 5 pillars that come from the 5 long-term commitments in one word. We failed miserably on one of them, but we now talk about the 5 pillars of this program in terms of influencing. So influencing strategies to position net zero at the heart, guiding. So we can't always provide the support, but we can guide people to the support available, sharing challenges and solution, building evidence and using evidence for data visualization and intelligence gathering, and understanding what a just transition for this industry means. So our vision of this program is that everyone in Scotland's food and drink industry understands net zero, knows where we're going, and knows how to get there. And we describe our purpose as leading Scotland's food and drink industry to net zero. I've put my email address on there in case anyone needs to contact me, particularly if you want to go on carbon literacy. Do let me know, or do get in touch if there's anything you think we can help your food and drink business with on developing a net zero transition plan. And I think that's me. So thank you very much for your time. And I'll try to stop sharing my screen now.
Thanks very much for that overview, Simon. It sounds like a great programme to get involved with. And I also wasn't aware that you had a fermentation group, so it was great to learn that. And I think that would be of real interest to our network. And also the carbon literacy sounds fantastic. So we'll push that out for you today to see if we can get more interested parties.
I should stress it's enteric fermentation, so probably not the fermentation that you.
Okay. Still might be of some interest to some of the network though. Absolutely. So moving on to our next speaker, we've got Craig Johnson, who's a co-founder and the Director of Strategic Partnerships at Enough. So Craig, I'm going to stop sharing and pass over to yourself to share your screen.
Morning, everyone. Hope you're all well. So I'm going to be talking about sustainable mycoprotein, as part of the broader net zero food. And we have a fermentation process, slightly different to what Simon indicated, but biotechnology is very much at the core of what we do. So we're based in Glasgow. We're a spin out from Strathclyde University, founded in 2015, and we ferment fungi using natural sugars from grains to make a sustainable product that we call Abunda. So in terms of the impact, there's no biorefinery in Scotland, so we're building we have built a full-scale facility in the Netherlands, and that will expand to 60,000 tons of mycoprotein, and I'll cover that during the presentation. The first phase is 10,000 tons. At capacity, that's the equivalent of 6 cows per hour in terms of protein. And just transition that Simon mentioned is very much one of our themes of moving part of the market from from animal protein to more sustainable protein. And you can see some of the impact in terms of CO2 emissions in terms of at capacity, and our company's vision is to make 1 million tons cumulative mycoprotein within 10 years. The product itself has been around for many years. I myself worked for ICI back in the 80s, and at that time corn was part of the ICI portfolio. So mycoprotein has been around for many years, so the regulatory approval is in place in Europe and in the States. So what is Abunda? Abunda is a mycoprotein, so we are a B2B company. We sell the paste that you can see there. So it's a very neutral taste. It's got a very nice structure because of the fibers from fermentation. So it's a very good bite taste, and has less off notes compared with products like soy or pea. As per lots of the presentations you're going to hear today, very much core is the UN sustainability goals, and it's a very versatile product that we have. I think it's a fascinating workshop, and you'll hear from other speakers who will cover insects, algae. So there's a broad range of plant-based protein, fermentation-based protein, cultured meat, products, and it's a broad church of customers, from meat eaters who might eat slightly less at one end of the spectrum, down to vegan at the other end. So very much our product fits within a range of consumers, and we're even looking at some products that are a mixture of our product with meat, so hybrid products, but most of our products are vegan. So in terms of the types of products, these are some of the examples that we've made. Probably our flagship product is our chicken breast. So the structure leads itself very well towards that. Very good source of fiber and amino acids, but really can be made into a broad range of products and very versatile. So on the right there we have fairly straightforward recipe with mycoprotein and some other ingredients to give very nice Thai crab cakes. So we're working with a whole range of end users. So in the public domain are Unilever, Vegetarian Butcher, Marks and Spencers, but a broad range of other brands and own label companies throughout Europe. So in terms of the process itself, we take glucose from grain. We have a continuous fermentation process. So the actual product is the biomass. So we harvest that product, and then I guess the trick that we have is that we patented a process to the waste stream, which is largely water but contains some sugars and fibers. We reprocess into a biorefinery, so there's a secondary fermentation. So essentially, there's no waste process stream. So because of that, process, it's really improves the overall sustainability and zero waste approach. And we have had support in the early stages from Zero Waste Scotland to help develop the product. As I said, the mycoprotein has been around for a while, so it's a little bit small, but top left is one of the original patents from Rackhovis McDougall for corn in the 80s, and then bottom left is the patent that we filed at the University of Strathclyde in 2014. And it really, on the right, there's a kind of schematic there showing the main process of a biorefinery with a kind of side process of mycoprotein and combining them. So as I said, there's no process waste stream. So it's a kind of a novel process, but building on the heritage of a food product that's been around for many, many years and through all the regulatory hurdles. So in terms of the scale and scaling up our fermentation, so we started at the University of Strathclyde and actually with some open access facilities from iBioIC. So you can see there the biostat down at 10 litres. So that's some of the early material that we produced. And then we needed food grade facilities to scale up. So we worked with Biobase Europe in Ghent in Belgium, really taking through from 150 litres there through to 15 metre cubed. So our full scale facility is 150 metre cubed reactors. So we operated at a tenth of the scale. It's also been supporting initiatives looking at the Scottish footprint for pilot facilities, but we needed food grade material for our trials. We also in Kinning Park invested in a scale down facility. So this is a 200 litre fermenter that you can see there on the left. On the right there is our first food grade production from there. So this was very useful in terms of looking at our process operating envelope. And we also, not shown in that picture, but adjacent, have a new product development facility where our chef, Michael Kilkie, works developing a range of products with customers. So though we're B2B, we also demonstrate some of the products ourselves. So as I said, there's no biorefinery in Scotland, so we had to look abroad. So this is our facility. So this is an artist's impression. I'll show you the real facility shortly. So we're on the border between the Netherlands and Belgium in a place called Saas-van-Gent, and we're co-located on a cargo facility. So if you look at the picture on the left-hand side, we take our glucose feedstock from a starch facility from cargo. There's actually a canal where you see N252, that's a canal, and grains are imported by barge, converted through to glucose. We take that directly into our facility, and then what's called the tie-in is where the waste from our process goes into a biorefinery and is converted through to ethanol and animal feed. So it's an ideal location. The plant shown there is has a footprint for 20,000 tons, but we can expand to the east on that map to up to 60,000 tons. I'm going to show a short video now, really looking at the construction, and you will see images of the starch facility and also of the refinery alongside our location. You can see some of the existing tags, so we can use fermentation. This also includes some of our within the building we have facility. So one of the things that is a very important, across Scotland with iBioIC is working in terms of our on collaboration. So we received a competitive 17 million euro funding through BBI-JU, and this has helped towards the cost of constructing the facility that I've shown. So I've mentioned cargo. We've also got a broad range of other partners within the project. So from an academic perspective, Wageningen University, product, Anglo-British products. So they're a beef company. So they're looking at the transition from from meat to meat alternatives. We also have LCE, so they're an Italian company looking at life cycle analysis. So I think the whole and that includes social life cycle analysis as well as more conventional CO2 and a range of other partners there. Lactips are quite interesting. So they're a French company that make bioplastics. So it would be pretty cool if we could package our material in in mycoprotein itself. So really just to come to a conclusion there. So we're aiming to produce 1 million tons of Bunda. That's 5 million less cows or 1.25 billion less chickens. And overall, as well as the carbon, the CO2, there's much less land use and water use than beef or chicken. So with that, I will conclude and look forward later on to answering some questions. Thank you.
That was great. Thank you very much, Craig, for that. That was really interesting to learn a little bit more about your process and your really strong sustainability with regards to that process, and the fact that it's zero waste as well is fantastic. And it was also really great to learn about your scale-up journey too, just a little bit more around that and how it was funded. And I think mycoprotein packaging sounds fantastic. We'd love to see how we can support that through iBioIC, absolutely. So we're now going to move on to our next speaker, who is Joe Palmer, and he's a product development manager at Scott Bio, and he's going to talk to us today around sustainable microalgae ingredients. So Joe, I'm going to stop sharing and pass over to yourself.
Okay, thank you. Okay, so hopefully everybody can see my screen now. So hello everyone, I'm Joe Palmer, Product Development Manager at Scott Bio. And in the talk today, I'm going to introduce you to how we're using microalgae to produce sustainable, responsible ingredients for the food industry, and also discuss about some of the challenges we're facing to make our product and plant more carbon neutral and more sustainable, and how we've broached some of those challenges. So I'd just like to firstly thank Kim, Lindsay and Carol and the iBioIC team for inviting me to speak today. I just wanted to apologise that I'm in the midst of COVID, so I'm probably sounding slightly more snivelly than normal, so hopefully you can bear with me. Okay, so as Simon mentioned in his talk earlier, I think food ingredient manufacturers are trying to find ways of transitioning to more environmentally friendly, sustainable products, and this reflects as well what consumers are after. But this poses a bit of a challenge, as we found, moving to some of these more natural ingredients due to both price points and performance sensitivities. So specifically in our kind of target sectors, which is first and foremost the natural colorant market, there's some challenges. There's limited sources of natural blue. The majority of this blue pigment, called phycocyanin or spirulina extract, is derived from China, and it's grown in open, sort of low intensity pond systems. And these pond systems and microalgal ingredients that are derived from such systems face a number of issues, including product quality, product availability, and various other supply chain issues. So our strategy at Scott Bio has been to kind of develop a hygienic, high-yielding, modular photobioreactor system that can generate spirulina and other microalgal biomass where needed for processing into healthy food ingredients. So the platform that I'm going to kind of talk to you about today, not only is it about 300 times more productive than the average productivity of one of these pond systems, but the platform and the integrated multi-product DSP line can be scaled up to match increased demand for microalgal products with a constant high quality output achievable sort of all throughout the year. So I think there's kind of three areas which kind of differentiate Scott Bio from other algal companies, and I think have really increased our likelihood of succeeding where sometimes some other biotech startups have often struggled. So kind of firstly, we had some really kind of really key initial conversations with some really large global food corporations, and they identified that low output variable quality products and risky supply chains were the things that were preventing their companies. So we talked to the likes of Mars and Pepsi, and these issues were preventing them from transitioning to natural microalgal ingredients in for their product ranges. So we developed our patented scalable platform, allows us to serve the needs of these large companies by delivering these high value, consistent, high quality products. Secondly, we have developed a scalable and economical co-product downstream production line for manufacturing products straight from the fresh algal biomass, which I think is quite an important bit. So we don't have to put in an additional drying step in there. So that, again, that helps us be more sustainable and more economical. And I think thirdly, and for me most importantly, is we've worked with a number of end users, and we've collaborated with numerous academic partners as well to understand and overcome some of the technical barriers which prevented sort of more widespread use of natural colorants and novel proteins in various food applications. And we have developed, because of those conversations, more sustainable, better performing products that are specifically tailored to the food industry. So we're underway with a site build in Livingston, just outside Edinburgh, which is going to demonstrate our new bioreactor platform. And we anticipate at full capacity of producing roughly 14 tons of this natural blue colorant and an additional 30 tons of other algal proteins. And our philosophy is to develop, as I said, a hygienic modular system that can be deployed anywhere in the world, ideally close to where the products are actually needed, and preferably in locations with access to renewable energy. And our PBR design can be scaled out basically to match any output required for products. As I said, our kind of another advantage of our DSP line, it's been scaled and tested and uses fairly standard food manufacturing equipment to kind of aid rapid deployment as well. And we've developed the plant with sustainability in mind, and throughout the next months and few years, we'll be introducing a number of features to help minimize our carbon and water footprints. And so the products that the three product lines that we're launching, and natural 4 products. Firstly, we've got our natural colorants. We've got Scott Bio Blue, which is designed to be a mimic of the market leading natural blue pigment called Lena Blue, which is manufactured in Japan. As I'm going to briefly touch on in a second, that has a number of kind of performance issues. So over the last year, I've been working to develop a kind of a heat stable product called Scott Bio Super Blue, which allows us kind of to penetrate into new product areas, and then shows advantageous kind of stability performance. So when we make that blue, we have quite a large amount of biomass left over, and one of the kind of main kind of remits of my work from when I joined Scott Bio was to find ways that we could utilize this other biomass. So we're hoping over the next few months to launch these 2 other products. Firstly, Scott Bio Protein, which is a nutritious, complete protein. It's roughly about 70% protein for use in alternate meat products. But also, as Craig mentioned earlier, we've also been looking at hybrid products as well, where we can introduce our protein into meat products such as sausages and gravies to displace some of that animal-based meat. And also as well, we've been looking at developing functional ingredients as well. So this is a completely neutral product. It doesn't have the same color and flavor as the Scott bioprotein, but it actually has additional functionality as well. So it's used in smaller amounts rather than a bulk protein. It's used to replace things like egg in mayonnaises, or to remove other functional emulsifiers or fat binders in other products. So in terms of the natural colorants, natural phycocyanin has its issues, as I've said. It's typically, like a lot of other natural colorants, it's not particularly UV stable, and it has issues with heat stability in particular. And the unfortunate consequence of this is, with a lot of thermal processes used in the food industry, it causes the product to firstly decolorize and to change color. But as you've probably seen, when you put egg whites into anything hot, it actually curdles and aggregates, which makes the blue product kind of unusable for a number of food products. So what we've actually designed is a heat stable product through formulation changes. So as you can see here, this is our super blue compared with the market leading leaner blue and conventional blue, just in its natural form without any heating. When you add it to a boiling buffer, you can see with leaner blue and sort of natural phycocyanin, very quickly it aggregates out of solution. So if you were making sweets, or you were making adding it to Gatorade or a blue drink, this is what would happen during a kind of typical pasteurization process. You'd get this curdling and aggregation of your product. And similarly as well, so the first one was when you add it. This is when you pasteurize it with the blue already in. As you can see, our super blue product doesn't experience any of these aggregation issues, which have been limiting for all of the other phycocyanin products on the market. So we think this allows our product to, as I said, penetrate into other markets and products which have previously been unsuitable for spirulina extracts. So I've had quite a fun job over the last sort of 6 months or so. We've been making sweets, we've been baking, we've kind of been trying to demonstrate the utility of the super blue product in model systems. And what we've found is it's particularly suitable for confectionery and sugary drinks, even working at quite low pHs, which often are quite a lot of sort of beverages and sweet products are. We don't see any of this flocculation. And in actual fact, when added at about 80 degrees into a buffer or a sugar syrup, over 96% of color intensity is retained. We've also found as well in dairy products, even sort of using typical pasteurization processes like flash pasteurization or high temperature short time, the color change and degradation is minimal. So we think the majority of dairy products as well are kind of suitable uses for our super blue product. Onto the vegan proteins. So as I mentioned, we have two products that we're planning to launch. The first is a ready colored bulk protein, which we think is suitable for gravies as an ingredient to be kind of sort of mixed into hybrid meat products. It's 70% protein. It has a digestible indispensable amino acid score of 86, which makes it pretty much sort of on par with soy extracts in terms of its digestibility, and typically more digestible than most other plant proteins. It's high in iron, magnesium, fiber, and a number of other vitamins and nutrients. And also importantly as well, it's allergen free, which offers advantages over potentially some soy and wheat based proteins. And then our vegan emulsifier functional ingredient product, again, has that color removed from it, so that it's typically used in smaller amounts, but again, it doesn't impart any color which the Scott bioprotein does. So we've been working with a number of partners this year to kind of explore the functionality of these products. We've had a number of really rewarding projects with iBioIC, including one we've just finished working with Queen Margaret University. And that was to look at how the functional ingredient could be used both as an egg replacement in mayonnaises and also to replace soy in sausages. So just kind of briefly to overview some of that from the sensory panel analysis, the conclusion was that the sausages made from our Scott bioprotein ingredient were actually preferable to the conventional recipe using soy isolates. And similarly, we've managed to make very tasty, visually appealing mayonnaises. So the plan is over the next few months is to scale up the manufacture of these products and do some larger commercial trials with end users. So our current focus is admittedly on delivering an operational site by March, which is going to be resultantly a busy few months for us. And then we plan after that to transition our R&D and engineering focus into improving the performance, productivity and sustainability of the site for the products we produce. So as you kind of gather, growing microalgae using LED-based technologies does require significant amounts of energy and water. But the PBR design and the vessel design, which we've patented and we've been using, allows us to use both of those resources more efficiently. We yield greater productivities per watt of energy than most other systems available, and we use lower culture volume. So what we've actually found is in terms of our production volume, we've scaled down. We still have a number of initiatives over the next few years to reduce our water and nutrient use, including the reuse of our spent culture media by removing large, what we found to be antiviral molecules from that, which allows us to reuse a lot of the water that we use for our culture media. And we want to move towards full water recycling capabilities from 2025. We're also using grant funding to explore how we can use waste CO2 from other food industries to feed to our spirulina, which will help minimize the carbon footprint of our products. And again, in terms of our products, we're optimizing DSP performance to reduce our water and energy. And we think a significant milestone for us is the full commercialization of those protein products, which I mentioned, which basically mean that we can use all of the biomass we produce. And I think another one internally for us is being able to replace toll spray drying with a more efficient energy drying process, or bringing that drying capabilities in-house. That's going to be a real kind of step forward for us. So yeah, basically, just to conclude, this is what the next few years looks like for us. We're going to be launching a site. We're going to have Super Blue product available as of April. So if you think that's a product that you would like to trial, please get in touch with me. Protein products will be following from the summer and into the next year. And then we're going to be increasing our production capacity from starting off at about 1/4 of a ton per month up to full capacity next year when we bring our second bioreactor online. And just very quickly, yeah, in terms of products, we're going to hopefully be bringing out acid and UV stable pigments in the future. And we're also going to be looking at how we can use these pigments in cosmeceuticals, nutraceuticals, and as therapeutics as well. So please, I've kind of whizzed over everything today. If you're interested in the product or our processes, or you want to ask any more questions, please just drop me an email, and I'll be happy to answer any of your questions. Thank you very much.
That was fantastic. Thanks very much for that, Joe. It was really great to hear about your platform and just how efficient it is. And it was also great to hear about your new site in Livingston. That's really exciting news. And also to learn a little bit more about your products and the ones that you're launching, those products. That was great. Thanks very much. So next up, we've got Craig Sterling, who's the Chief Commercial Officer at Quantech, and he's going to be talking to us today around sustainable bioplastics from shellfish byproducts. So Craig, I'm going to pass over to you to share your screen.
All right, give me 2 seconds here. All right, are you seeing this yet?
Not yet, Craig. Oh, that's it coming up now. Just taking a little second. Perfect.
All right. Let me start. You see the starting slide?
Yep. Perfect. Thank you.
Excellent. All right. Well, good morning, everyone. First of all, thank you for the invitation to be part of this event. Always happy to do things with iBioC. We have a very good relationship with iBioC, and so I'm always happy to support these events in exchange as well. So thank you very much. My name is Craig Sterling. I'm the Chief Commercial Officer for Quantech. I was actually CEO of the company for 3 years, but now I've decided to focus on just the more fun stuff, I guess, the scientific stuff and the commercial opportunities that we have built over the last several years for Kuntech. So excited to talk about some of the developments that we have coming out for 2024. One of those is, well, first of all, let me start with the kind of background of the company. We've actually developed a proprietary process to extract a number of raw materials from shellfish industries, shellfish waste from the fishing industry. One of those is actually a biopolymer that's called chitin. That biopolymer, chitin, is the second most naturally abundant biopolymer in the world. It's what's used to give the form and structure and protection to exoskeleton insects as well as crustaceans. So it gives it the hard shell on the outside for shrimp or for crab, or if you think about black soldier fly or cockroaches, any of those things, anything that has an exoskeleton, as well as mushrooms. That exoskeleton is made up of chitin along with a number of other materials. We developed a process to extract that naturally in a way that actually maintains the entire chain length of that biopolymer, which has never been done before. So as a result, while chitin is not new to the world, and some of these applications are not necessarily new, the realization of some of these applications that have been thought to be possible haven't really been obtained until now, because of the fact that so much damage can happen during the extraction process. And I'll talk about that a little bit more. But so how did we start? Why was the reason? What's the problem? Well, one of the things we looked at was the plastic problem. So I was reading an article in Science, I think it was, and it talked about that they had figured out a way to measure the weight of every single person on the planet. And I was like, oh, that's interesting. So I kind of read the methodology and was reading through that. But separately, I realized I also knew all these numbers from the plastics industry, because we're trying to eliminate single-use plastics. So when I looked at this number, I realized that there are 381 million tons of plastic output on Earth every year. That outweighs the total weight of every person on the planet. There's 287 million tons of people on the planet. So we actually output more plastic waste by over 100 million tons than we have in our own existence as people. And if you look at that by 2035, that is expected to go all the way up to 817 million tons. So triple our weight. We output 3 times more plastic waste alone. Doesn't include the carbon, doesn't include any of the other stuff that we do to the planet, just plastic waste. So that is a pretty staggering figure. And of course, the impact is substantial. And we don't know all the impacts yet, but one of them is, of course, the damage to the marine life. Over 1 million seabirds, 100,000 marine animals die every year from plastic. There's also the microplastics that are entered into our system and the food chain, all things that we don't know what the long-term impact is. What we've done is we've said, this is a problem. Packaging is important, but we've developed a biodegradable, ocean-friendly, naturally antimicrobial packaging to replace single-use plastics. And that's actually our very first prototype bread bag there. That baguette there is actually produced. We still, believe it or not, have that. One of the things with the shellfish waste that comes out, so the fishing industry actually produces a ton of waste. They're not able to use the entire body, right? So if you think about a lobster and how much you eat of an actual lobster, you're only eating the tail meat and the claw meat, right? So there's all this other stuff. There's a shell, there's all these proteins, there's all these fats, all these things that are really being discarded either at the ocean, or if they're landed, they're being incinerated, because once the body of the animal is landed, it becomes a biohazard and it has to be incinerated. Well, that incineration is a huge carbon footprint of its own. So if you look at about half of that being incinerated, for instance, 13.9 billion tons of CO2 emissions, that's if half of the food waste that's landed is incinerated per year. So we're instead taking that, putting it into our net zero process and extracting the biochitin, crystal chitin is what we call it, through our biological process, which has enabled our very first plastic packaging replacements, which includes our dry goods packaging, which we just released and is coming available this year. So that is a window box. Think about window boxes for like cake or for food, for shells, for sandwiches, etc. One of the things about window boxes I didn't realize is that there's about 1 million of these used per day in the UK. Everyone loves to grab and go sandwiches. You typically get them. You can pull that top lid off, and that has that film on top. You pull out your sandwich, and then you usually throw the film in the bin because it can't be recycled in most places, and then the bottom cardboard in the recycling. I didn't realize that that bottom cardboard is not recyclable, actually, because it is laminated with plastic. So in order for that film to protect the cardboard from the mayonnaise and the grease and stuff and the oils that are inside the sandwich, it needs to be laminated or coated. And that lamination or coating is plastic-based. It's a fossil fuel-based coating of laminate. So we've done two things. One is we've created this film that you can see here in the middle there. It's crystal clear, and it's completely compostable and biodegradable, all natural. If it goes in the ocean, it simply will disintegrate. In fact, it is a marine base, so actually will help the water. The second thing we've done is we can actually coat the inside of that cardboard with the same material that we use for our film. In doing so, we've eliminated that that negative part of the paper packaging that doesn't allow it to be recycled. You can actually now throw the entire package without stripping anything into the paper recycling bin. And that because of the chitin and the compostability of the material that we use to laminate and then we use to create the film, the entire paper box can be recycled in a normal paper bin and recaptured. So very rare, very new, very different. You don't have to separate it. You don't have to worry about that, and you can recapture all that pulp, which is extremely important. Some of the features of our material, of course, as I talked about already, is that it's clear. You can see the clarity that we have. It's flexible. Acts very much like any plastic, but it's not plastic. And it has the additional benefit with some of the formulations that if you were to make just a bag from it, you can actually extend the shelf life of baked goods and produce, because the film itself actually has the ability to wick moisture while still protecting the product that's inside. So if you take an experiment that we did, which is we took 2 loaves of freshly baked organic bread, and we put one in its regular packaging, and then one goes into our packaging. And we look at it after 2 weeks and after 7 weeks. So if we did that, if you look there on the lab bench, in the upper left-hand corner there is the standard packaging. And on the right-hand side is our packaging. So you can see after 2 weeks, the mold has already started to occur. Typically occurs in 5 to 7 days in most markets for baked goods. The catalyst for the mold is the water, right? The moisture that combines with the yeast and the bacteria in the breads. That's what's the catalyst for the mold. When we remove that excess moisture through desiccating features of the film, we're actually able to extend the shelf life of the film. You can see on the right-hand side, after 2 weeks, that film looks very fresh, very good, very edible. After 7 weeks on the lower left-hand corner picture, you can see that looks like a green troll doll from the 90s. This thing's about to grow legs and walk away. On the right-hand side, you can see after 7 weeks, no molding. Now, it does look like it's a little bit drier. In fact, probably at this point in time, after 7 weeks, it may be a little bit too dry to eat. Probably a 0 carbon way to make croutons. However, you can see the net effect is that somewhere between 2 and 7 weeks, you still have a very soft, very fresh loaf of bread that has now that hasn't molded, but has now tripled or quadrupled the life of the bread, or longer. And the same can be done with produce. If you look how it compares with other films on the market, if you look at the typical, this is just a snapshot. All the different films, the things that everyone would like to have: home compostability, the ability to drop into existing film manufacturing, very similar mechanical strengths our films are, the Kunsei films, similar properties in oxygen, water, vapor barrier properties, and of course, sustainable inputs. And the carbon neutral. But you can see we really do check all the ticks of the boxes at the top. And we compete with a lot of different bioproducts that are out there, and not all of them hits all these. Another really cool part of our film formulation and our coating formulation, our crystal coating formulation, is that when we coat that box, not only is it now recyclable, but the entire box becomes stronger. Chitin actually binds to the pulp of the paper, and it makes it very strong, actually. So it means you can also use less pulp when you make the box, and you can have it be just as strong when you have the coating on there. So you get a dual effect with that coating of not just protecting it from oils, which is very good. It's 100% oil resistant, not 100% water resistant. Very good water barrier, but not 100%. That's one of the things that does have to be considered, but very good for oil. But when you look at producing this film, this coating, and put it on the window box, now I can recycle the entire box, but also I can use less material. So we have actually produced from scratch our own pulps and windows as well, just to see how that looks. So we can make very thin papers with the lower right-hand corner there. And if you go to the lower left-hand corner, the upper right corner in order, and of course the upper left-hand corner, those have more and more pulp. So we can actually make a paper that's co-bound with our film formulation or our coating formulations. And they're very strong. You can see how strong on the upper left-hand it actually looks. Very smooth, very strong piece of paper that was made just from combining our pulp that we make with our formulations. Another thing that we've been able to do is to show kind of through the coatings. I can show you that the oil resistance. So this is just, I believe, olive oil. You can actually see where we failed to meet the coating perfectly in this lab experiment here. You can see there's a little bit of staining on the upper portion there on the crease where it didn't get fully coated. So you can see where the oil did transfer through, but you can see here this never did go through or pass through the coatings at any point where it was covered properly. On the flip side of the spectrum, we can actually do the opposite. We can make a film that actually dissolves very quickly as well. So one of the other applications we've looked at, or two applications we've looked at, is dissolvable sachets. So one for laundry, like there's pictured here. You know, those are made up of PBOH, which is not good for the environment. So you put those in your washing machine or in your laundry machine, your dishwasher, it visibly disappears, the sachet, so you think it's gone. It actually does leave a residue in your pipes, and it builds up over time. It gets gunky, but also that PBOH isn't good for the water. It's not good for the environment. The nice thing about chitin is that chitin is actually used as a water treatment for treating water in different applications in different markets in the world. It's used for pool water treatment as well. It's also used as a fining agent for wine. So it's helpful for water. So if you put this in, you make a soluble sachet with the detergent in it, not only does it dissolve 100% in cold water within several minutes, as you can see on the right-hand side, but it doesn't leave any residue in your pipes, and it actually helps treat the water. So it's already given initial water treatment as part of that. So it's actually effectively, hopefully, making the detergent more effective as it's laundering the clothes or cleaning your dishes. The other thing we've tried with this as well is just making a dissolvable sachet that has dry spices in it. So you just take that spice sachet and, think of like ramen noodles or, mac and cheese, any of that stuff. You just drop the whole packet into the water and the whole thing dissolves and disappears. And then you can still have the spice or the tea or the cheese packet or whatever without having plastic. A longer term development that we've looked at and worked on because of this unique ability of our chitin, because of the high molecular weight that we have, one application that's also never been successful before is the ability to produce fibers. So we've been able to produce very strong, very soft, but extremely strong microfibers using the chitin and the chitosan. Now, this is a longer term project. Developments that we use for wound healing, for textiles, for different applications. But just wanted to highlight that. It's just another one of the features because of our ability to extract the chitin in the natural way in which we do it. So some of the differentiated product tech that we talked about here today, there's a lot on the slide, but home compostable films, transparent, strong, they enhance the shelf life of the products within there for fresh baked goods and for produce, all under our CoonSave products. Chitosan itself is permitted in cosmetics. It's been used now for spinning our fibers. It's good for biomedical applications, and also, of course, for the coatings in our films that we're producing. So it does strengthen the paper. If you looked at the coatings, it's oil proof. It does enhance the water resistance substantially, and it is fully recyclable. All of this, again, is extracted from waste that would otherwise be incinerated. Biggest reason is, again, we have the only process in the world that maintains the entire biopolymer. And it provides, because of that, all the characteristics are being unlocked that are there as far as that chitin and its ability to enhance some of the film forming capabilities or our coating capabilities. This is eliminating a CO2 emission that already exists in the world as well. If you look at the chemical process, it damages the biopolymer. So there's still the fact that you can use the chitin and chitosan for certain applications, but not for some of the applications that we've developed. Does denature the polymer, and it has, because as a result of that, rather poor film making and fiber making effect. So I'll show you a slide next where we have purchased an ultra pure, it was called an ultra pure chitin from the market, and made a film with it. And you can see the effect here on the lower left-hand side. That's the competitor chitin, and that's from the purest chitosan that we could buy at the time, and made a film with that. You can see it's very orange, like very caramelized. That's because of the damage that happened to the biopolymer. It's a polysaccharide. It's like a sugar. So think about creme brulee. when you torch the top of a creme brulee, you're caramelizing that. That's exactly what's happened with the when they're extracting the chitosan or the chitin from using the other materials, using the chemical process and high temperature process. You can see our film is very clear, in fact, crystal clear, which is part of our trademark for Kuntec. So just another validation slide here for our chitosan. Really just talks about the higher molecular weight that we have than any of the commercially available chitosan on the market, which is some of the reasons why we're able to do some of these applications. So I think I've got about 40 seconds over, but thank you very much. Looking forward to any questions at the end. Or if anyone would like to contact me, I'm sure they're happy to provide my contact information.
That was fantastic. Thanks very much, Craig. And I think we've already got a few questions coming in for you, but we'll keep the questions to the end and then we'll move on to them afterwards, if that's okay with everyone. Yeah, it was really fantastic to hear about all the products you're developing. In particular, the extension of life through your films was fantastic. And also I thought the plastics that you shared at the beginning was absolutely staggering. I wasn't aware that was what the stats were. So it was really great to learn.
It's a staggering statistic, yes.
Yeah, it really is. I'll use that one. So next up we've got Jeremy Dentis, who is the CSO at Supplant, and Jeremy's going to be talking to us about sugar replacement from crop residue. So Jeremy, I'll pass over to yourself.
Thank you. That should now go into full screen. So it's got to be one, doesn't there? Great, thank you very much. So we've got a few slides in. Thanks very much. Yeah, so we'll go on talking about the keeping intact the second most abundant biopolymer on Earth to breaking down the most abundant biopolymer on Earth, being cellulose, and turning that into food ingredients, because that's what we do at the Supplant company. So just a little bit of background about the company, where we come from. You might recognise us, and it's still our UK registered name is Cambridge Glycoscience. Not so customer friendly, a bit sciencey. So we've changed that over time. Actually changed names a couple of times over time, and now settled on the Supplant company going forward. So at the top there are the people we've kind of worked with to commercialise our ingredients, which I'll walk you through. And at the bottom are the people who've thankfully put their hands in their pockets to a relatively considerable sum to help us do what we've managed to do so far. So we are an industrial biotechnology company. We take crop residues, things like oat hulls, corn cobs, wheat bran, wheat stalks, anything you can think of really that has these biopolymers in them, be it cellulose and hemicellulose. And the core of our process is an enzyme reaction. So we generate bespoke enzyme cocktails, and those enzyme cocktails break down those long chain sugars, the long chain polysaccharides in those agricultural byproducts into shorter chain oligosaccharides and sugars that form the basis of our products. So we have two main products, one for replacing sugar in food, and the other one that replaces starch and refined flour in food. But when you get novel carbohydrates, and a bunch of clever chemists and scientists always have a bit of fun, so we've also developed some ingredients that will actually go into things like the personal care industry, materials and beyond. So we're not just a food company, we're actually an industrial biotechnology company that happens to have food as our first two ingredients. So the important thing about this is also that we have no bespoke hardware. So we're not engineers, we haven't invented any kit, and we've heard scale-up stories already this morning and how challenging they can be. So actually eliminating that risk and using equipment that already exists in the food industry and food adjacent industries is really important from our perspective. So we've protected the patent, or the patent portfolio protects these ingredients that we've made, covering the entire value chain. Those strongest ones really being around the composition of our ingredients, so what's in them. Whatever you do, you can't it's easy to tell if you can infringe on those patents, but they also cover the manufacturing process all the way from the raw material through to our ingredient, and also the applications. So you can imagine in food products, what happens when you take these novel ingredients and you heat them up and cool them down. They might behave in particularly interesting ways, and thankfully they do, in useful ways. And so we protect those as well. And so that patent portfolio is growing nicely, and as a young company, that's one of the those first kind of assets that you could really build that we can build value with. And just to mention that our engineered strains are also protected more by know-how than by patents, but they are deposited at the NCIMB up in Aberdeen. So I'll take you through our first ingredient, really what the motivation was behind the foundation of the company. And it's really this cheesy line that we use. So Diet Coke, Coke Zero, been around for over 40 years now. Diet Coke actually launched in 1982. And so sugar reduced, alternatively sweetened beverages been around forever. But no one's made Cake Zero yet. And there are some fundamental reasons behind that, which I'll come on to. But it's actually quite surprising because most people associate kind of sugar and drinks and sugary drinks, and sugar taxes focus on drinks as well. But actually, it's a smaller market for sugar. It's about 20% of the size. 5 times bigger market is actually the sugar that goes into food. So it's everything you could possibly think of on the supermarket shelf probably has some sugar in there. And that's what we're addressing, because at the moment it's a completely untapped market. There's a fundamental reason for that. The existing sugar replacement ingredients suffer, in 3 kind of core ways. One is on the functionality side. So here on the top, you could see just a normal kind of sugar cookie, chewy cookie, made with our ingredient, normal cane sugar, and then some of these alternatives that are out there. And this is 100% replacement. So taking all the sugar out, the normal sucrose out, and replacing it with the sugar alternative. So, disclaimer, it is possible to formulate perfectly good food products by putting less than 100% of the ingredient in. But just as a kind of in extreme example, this is what you get. So functionally, they just don't work, and that's not really a surprise. If you think back as a scientist, as a chemist, you might think that the drop-in replacement for ethanol is ethanol. The drop-in replacement for sucrose is sucrose. So to expect one molecule, be that a sugar or a sugar alcohol, to behave in exactly the same way as sucrose, you wouldn't expect it. And so that's exactly what we've done. Is that our ingredient is actually a mixture of sugars and fiber, hence sugars from fiber, that actually performs those roles, the various roles that sucrose does in food, and all those various molecules in the combination actually give you that final functionality. So we have a tick in that box. The other side is cost. All the current sugar replacement ingredients, except one, and that's xylitol, which can be made from wood, are actually made from starch and sugar. So you don't need a Nobel Prize in economics that you're going to struggle to beat starch and sugar in terms of cost if you have to do some processing on the top of it to actually make your ingredients. So you can never beat them on cost. Whereas if you go down the left-hand side of that diagram, starting with agricultural side streams, the cost base is much lower. And so you have room to do your manufacturing and then to produce your ingredient at cost parity with the existing sugar and starch ingredients on the market. You also then have the benefit of sustainability by going down that route. You're not, you're using crops that are already grown, and you're not not having to put any greater inputs or more inputs into that agricultural life cycle. So things like water, pesticide, fertilizer. You've already used that all, so you might as well use everything that's on the crop, on the field. And then the final angle is on food security. And actually, you could produce more land, more food from the same area of land by going down that approach. So you've got a tick in all those 4 boxes. We also heard earlier that it's not always possible to do everything you want in your back garden, and that's certainly been the case with us. So sugars from fiber, our ingredient for replacing sugar in food, is a novel food according to the UK and EU definition, and that brings its own challenges, mainly regulatory ones. So actually, our first market was in the US. That's not because people always say, "Oh, you've gone to the US, chlorinated chicken, really low food standards." That's absolutely not the case. Most of the work that's been required of us to produce regulatory dossiers in the US is exactly the same as has been requested in the UK and EU. The difference has been the US has a stepping stone, has this process called self-affirmed GRAS by expert panel, which gives you a route into the market at lower kind of inclusion levels in food products without having to go the full, federal FDA or UK FSA or EFSA dossier submission. And so that's our first market. And so we have ingredient manufacture in Texas, as well as making some products using those ingredients in California and also in Indiana. And the nice thing is also we've got a double-blind crossover study, so the Rolls-Royce tolerance study, showing that our ingredient is tolerable up to 45 grams a day. That's because it's the highest amount we tested, not because that was the tolerance limit. And just for comparison, the recommended amount of sugar per day is 50 grams. In the US, it's a high, but people actually eat more than that. In the UK, where we're based, we have our pilot plant and SALSA accredited. It's a food safety registration on our production sites in the UK, meaning we can make food that people can actually eat using our ingredients. And we've also outsourced our manufacturing up to kind of 20,000 litre scale, 2 cubic meters per hour flow throughs. So where you might imagine TRL 6 or 7, so showing operation in a real world environment. And we're about to do the regulatory piece in the UK and in Europe. So how do we launch these ingredients? So we were very lucky to partner with Chef Thomas Keller. He has 7 Michelin stars. The French Laundry in California has 3 Michelin stars. Per se in New York has 3 Michelin stars. And just your everyday 1 Michelin star for the time in between. But he was a great champion. That's him outside his Bouchon Bakery, which is his little bakery chain, where he went and served ice cream just to passers-by for the very first launch of the ingredient. And then he incorporated it into his menus at his 3-star restaurants. So there is a kind of an onion tartlet where the kind of caramelized onions are with our sugars, a ketchup just showing everyday kind of applications, so mainstream applications. That's lamb with a cassoulet, so equivalent of baked beans, and then in dessert where you might expect to find sugar ingredients to make a sponge and also an ice cream. And off the back of that, we launched a range of CPG products that we also co-formulated with Chef Keller in chocolate and shortbread, just to show kind of the mainstream consumer purchasing, retail acceptance, and that we're not just a bunch of scientists, that we can actually make and sell stuff and run a business. And it's gone well. People have liked the chocolate they've tasted. So International Confectionery Magazine said couldn't tell the difference. And Chef Keller's been a great proponent of everything that we've been doing. But really, exactly, also mentioned previously, it's one of the challenges we're going a bit later in the program, is that ultimately we're a B2B ingredient supplier, and the way we make the most impact, talking about net zero and sustainability, is actually with these large companies who produce products that are on all the supermarket shelves, and so those volume things that we all love to have to eat and have a treat with, are really where we're aiming at. So to that end, we actually have signed 5 agreements with various multinationals. 3 of these projects are actually really exciting ones where they take a raw material in their supply chain, we make an ingredient with it, and we give it back to them to put it in their end products. So that's a great circular economy narrative. And for those who've interacted with large companies, the marketing department is usually a very good way into them, and that's what we found by being able to tell those sorts of stories. We also work in food service across the US. So we're in hospital catering, actually made in food service and with a group called Aramark, and also across the University of California, where we've made a bakery base that goes into their their outlets in their universities. And we think our universities are big, but across the University of California system, there's about 500,000 staff and students. So actually, these count as quite big accounts. And so these are our first 2 ingredients. So sugars from fiber that makes sugar reduction at scale in bakery, chocolate, ice cream, and cereal. And then also we validated our second ingredient, which is this ingredient for replacing starch and refined flour in food. So that ingredient is actually on sale, and our pasta's on sale in the UK. Also launched into food service across the University of Cambridge. So colleges and students at colleges are now eating what we're calling our pasta made with grain and stalk flour, and that really, it is a really nice fillip to be able to do things closer to home rather than outside and far away in the US all the time. Maybe finally to circle back just to the the biotech at the beginning, our use of enzymes derived from fungi to break down these long chain polysaccharides into oligosaccharides and other sugars that form our ingredients. To really talk about that really Venn diagram that we have to hit or are attempting to hit the middle of. So the health one, the ingredients that we make, so the sugars from fiber, it's up to 70% fewer calories than normal refined sugar. So refined sugar is 4 kilocalories per gram. We're in the region of maybe getting that down to 1.2, 1.4, depending on the formulation. The really interesting one is on the blood sugar spike. So I think most people have experienced a bit of a sugar rush and then a bit of a sugar crash off the end of that. Well, our ingredient, that blood sugar spike is reduced by 88%. So you just have a very small increase in your blood sugar level. And also these ingredients being prebiotics mean that they're good for your gut health. And we've done those studies. They're rather less glamorous studies, but showing how the microflora of your gut changes over time with consumption of our ingredients. On the climate side, sugars from fiber is 45% less CO2 emissions versus growing cane sugar. So that's a big difference there. But really on the water and the land use, fertilizer, pesticide, those are really the huge drivers there. So 90% less water and 97% less land. And then on the food, and that drives food security with the reduction in land use. So we can make up to twice as much food per unit area, be that acre per land of land, increasing the supply chain resilience that you've got there in food security. So we actually did a study on this and wrote a white paper and showed that in the UK, if you made the flour in our route, so our grain and stalk flour, if you made all the flour in the UK down that route, the UK could be self-sufficient in flour today and actually have enough flour to satisfy the population as it would be in 2050 as well. So we've actually got an abundance of everything that we need to make these staple food ingredients on our own land. It's just a case of unlocking that and actually taking out the first two ingredients. And if you replaced half the sugar and half the flour, preliminary data, but you could reduce greenhouse gas emissions by about 1.5%. And that's a big chunk considering the UK emissions are about 0.8% of global greenhouse gas emissions. So I'll leave you there. Thank you very much for the opportunity to talk and look forward to taking some questions afterwards.
That was fantastic. Thanks very much for that, Jeremy. That was the first time I'd heard Supplant speak, and I really enjoyed your presentation there. And sorry, I'm just quickly sharing my screen, everyone. And I thought what you said around the fact that plant-based sugar production was on parity with existing starches and sugar was really interesting, because often cost is a really big barrier for kind of novel IB processes. And I also thought your flour figure that you finished on as well was really interesting too. It was a great presentation, so thank you for that. Next up, we've got Kieran Whitaker, and Kieran's the CEO of Enticycle, and today he's going to be talking to us around insect farming technology. So Kieran, I'm going to pass over to yourself to share your screen with everyone.
Perfect, thank you very much. Can you hear me okay?
Yep, loud and clear.
Awesome, okay. Oh. And can you see the screen?
Yes, perfect.
Perfect. Thank you. Hi. So, unlike my name on the under my my image, my name's Kieran Olivares Whitaker. My colleague Will was going to be doing this. Yeah, I'm the CEO and founder of Entercycle. We are the leading provider of insect farms and insect technology. It's a pretty simple mission to help sustainably feed the world. Why? Because we're going to produce about 70% more feed to feed the Earth's population by 2050. And what most people don't realize is for every vegan, sustainable eater like myself and like many people in the room here, we have about between 5 and 10 people in the developing world becoming middle class. And they want to eat meat and they deserve in many circumstances to eat meat. They shouldn't be told what to do. We have to educate, we have to learn, and we have to help support. And also they have to learn their own mechanisms. So traditional protein is literally killing our planet. This the largest cause of deforestation is producing soya. One of the largest and fastest causes of emptying of the ocean is catching pelagic wild fish. At this moment in time, we're going to be about 60 million tons of protein short, and that's actually probably going to get larger and bigger as you see some of the global shocks that are happening. One boat gets stuck in the Suez Canal, prices go up. The war in Ukraine at the moment raises wheat prices. The rest of the commodities go up. Brazil has just had massive floods in the southern regions where soya is produced. El Nino is happening right now in the Pacific Ocean, so lots of the pelagic fish are going over to Asia instead of where they're traditionally caught in Chile and Peru. So like, there's all these kind of like I'm preaching to the choir here. We've got all these macro issues that are just going to get worse and worse and worse. And the companies that presented already, it's fantastic. Like it's amazing because we need more and more of these. But the reality is this is a global issue and a global facing problem. It's not just in the rich West. It's also in developing frontier economies. And I've seen it firsthand. So I actually came from a very different background from most people here. I was a scuba diving instructor. I lived in Southeast Asia, Central America, South America, and I've seen the same three things. Dead coral reef, which is where all the baby fish are, deforestation on land, and basically no more fish left in the sea. And literally, I've seen it with my own eyes, and I said one day enough is enough. So I actually used to live on a beach in Mexico, really quite nice life. And actually, I came back to the UK in the middle of January, about a decade ago, and decided to actually do something about it. My background is in environmental design, but that's the reason and the drive and the passion is because I've seen it. I don't want to live that life anymore. So the insect time is now, it is happening all over the world. We've seen nearly $1 billion invested so far. And actually that's probably about 1.5 billion with the last year's worth of data. What Entercycle do is enable this industry to grow. So we are a pure technology company. We provide technology to either insect companies or people who want to enter the insect space. And it's growing at about 30% year on year. So it's a really fast growing industry. And that's because those customers, our customers, are targeting a whole range of markets. So either waste management on one end, all the way through to pet food, animal feed, even human food is now coming onto the table. We're sector agnostic. What we want to do is make sure as much insect protein. And the reason why companies are entering it is kind of like the same three triangles of sustainability, supply chains, and legislation. Insects were allowed to be fed into aquaculture and pets in 2017, and you've seen that, which UK led. And you've seen that regulation now just filter all the way around the world. Europe has now regulated chickens and pigs. And the US is allowing chicken manures and other types of problem inputs to be used in insect protein. So you're just seeing this fantastic proliferation. And our mission is to actually power that. We focus on the black soldier fly, BSF. There are 5 legislated regulated insects. And the reason we focus on this is because it's the fastest growing, it's the cheapest to produce, and it can be fed on the widest range of foodstuffs. So everything from traditional feedstock all the way through to human waste. We worked on the largest project in Africa, utilizing human waste as a latrine solution to actually then processing. And again, the whole beauty of this is that you're trying to produce as many insects as cheap as possible, while having both a genetic stock and a production stock. The industry at the moment sits around between 5 and 40%. We're able to reduce that down to about 2%, so that 98% can be actually used to produce protein, or can be used to process food waste, or can be used to create fertilizers, depending on that market forces. And it's an incredibly sustainable product. So compared to when it looks at land use, we're about 98% reduction. When you look at actual food miles, because people are now starting to integrate it vertically into their supply chains, it's nearly 100% because it can be done on farm. And for the replacement of either fish meal or soy proteins, it can look at saving 4 tons. When you actually start diving into different products that come out of an insect facility, it actually starts to become more and more exciting. So if you're just using food waste, it can be a carbon capture process of 2 tons. If you're actually utilizing the fertilizer to replace chemical fertilizers, because insect poo, it literally is soil. And then lastly, if you're actually then replacing that with imported products, you can see why this is so attractive to customers. And that's why the likes of Lidl Group in the US, Tesco's in the UK, Veolia, the waste management company, multiple farming groups, all the big feed groups are now all entering into this industry, either with partnerships or direct builds themselves. Last year was a year we closed our Series A. We've spent kind of 4 or 5 years perfecting the technology, and this year it's been all about commercializing. We've got a range of products all over the world. We've delivered a facility here in the UK, technology to America, and we're working on projects in the Middle East and the largest insect factory in the world. So depending on the range and the scale is required, we're very much agnostic to it. We have basically a dual pathway. We either provide existing insect companies with improvements to their systems. No single company out there has every single idea, neither do we, but we really focus on a key area, which I'll touch on in a moment. And then we also help new market entrants build their own facilities. So anything under about 45 tons a day, so kind of 15,000 tons a year. About 15,000 tons a year. We can help somebody build a full factory. Anything above that, we actually work with Beulah. So we're looking at factories up to about 200,000 tons of output production a year. We have a partnership now at Beulah. They approached us to actually go hand in hand. So those who don't know Beulah, pretty much 1 in 3 foods go through a Beulah machine somewhere around the world. They're a huge behemoth when it comes to actually producing sustainable food at a high volume and meeting the final customer's demand. In this partnership, we produce the breeding technology inside an insect factory, and they produce the production, pre-processing, and post-processing. So it's kind of a perfect hand in hand. It's an area they lack and an ability for us to actually mass scale. So with Beulah, we're working on multiple projects as well around the world. But we kind of, as I said, we're very agnostic because we have a suite of core technologies that go into any farm in any part of the world. One of the key reasons why we have that partnership and actually why we're able to deliver is we probably have the largest insect technology focus in the world. So we've hired out of a range of industries, whether that's huge factory builds, whether that's insect science, whether that's actually from the insect feed industry itself, here in the heart of London, but we are completely geographically agnostic as well. So we are literally working and deploying products all over the world. Our proprietary technical advantage predominantly comes around computer vision and AI. So we have a design of a full factory. I'm sitting right now in our kind of 1,000-meter square pilot facility here in London, where customers can come and see different aspects of a facility they may want and to kind of which level of automation. But our core that sits under all of that is the ability to count insects, count, manage, and move them through a system. And when we're talking about full-scale insect farms, we're talking about either billions or tens of billions of insects. And the reason why we use this is that if you're a traditional farmer and you don't know how many chickens you've got, how can you actually have a business model? How can you have control flows? So when we're talking about neonates that are the size of a grain of sand that can grow 5,000 times their body mass in a week, it's incredibly important to have that accuracy. And so the neonate counter is our first patented equipment that we're now shipping around the world. And essentially what it does is it counts, quantifies at the very first step, gives real feedback data, but can help basically produce customers larger, cheaper, more accurate factories. And this is kind of a small video of it playing here if it works. This is actually live on a customer site. So you can see there the neonates, which are a grain of sand. They are living, they're moving, they're very difficult to look after. But ultimately, we can produce, one of our machines can actually handle and produce and dose enough insects for about 25 tons of food waste a day. In some of the larger factories, we're looking at multiple deliveries of this, but ultimately it's a computer vision software machine. And then the next slide, you can actually see it now going actually into, this is on a customer site, and you can see there how fast the neonates are actually being delivered. So we're talking 3,000 per second, a very, very high efficient through rate. One of the other areas of technology we use, again, taking the same principle around computer vision, is the fly breeding system. So we can actually count and quantify flies when they're delivered in a cage. Again, sounds very fancy. The only reason we do this is we care about optimizing as many eggs out of the system as possible, but with that high quality control. So that means that we can actually use less flies to produce more eggs that then processes more food waste and then produces more protein. And again, this is technology we're now starting to deploy in our own facilities, but also into third parties directly. And then lastly, protein production units. We have a specialist design here because we are able to count and quantify so accurate on the front end. It means we can use quite simple environmental control systems on the back end. This is on the further end is the robotic system. So again, some customers are looking, especially in Europe, North America, at the much higher end. So instead of having human labor inside a facility, most of it's stacked, destacked, moved, and created using robotic arm systems that integrate both with the computer vision fly cages and into the dosing systems. Sorry, it's playing again. And then ultimately, what the direction that we're going as a company is factory as a service or facilities as a service, that we are able on the back end to fully manipulate and control a facility. That then provides with a traditional kind of SCADA system, an industrial SCADA system. But then on the front end for customers, they actually can see the performance of their facility in real time. And that's really important when working in the insect space, because you are dealing with living organisms. You have to have that real feedback data. In some systems at this moment in time, you only know what's happening. And if we have any problem about a month later, once you've gone through the full life cycle, we can actually provide this on a daily basis. So I know I'm absolutely flowing through that. This is kind of more my passion project, more than just a business opportunity, because the most important thing here is actually about helping to change the way that we feed the world and actually cause some tangible benefits, not just here in the West, but also in frontier and developing economies. So our target is to be able to tackle nearly 1,000 tons of CO2 by 2028, and 1 million tons of CO2, and about 750,000 tons of food waste or organic waste recycled. And that hits and fits into a huge amount of sustainable development goals, which is why you're seeing so many companies entering into this space, targeting a whole range of different kind of requirements, needs, or business opportunities. As I said, we are not farmers ourselves. We help people build and deploy their own facilities. So if you have any interest to actually come and build one yourself, whether you're based here in the UK, I forget to add one thing. Scotland is leading the way in the UK around insect protein compared to the rest of England. You have far more joined up legislators, regulators, who we already talked to. So if anyone is looking to actually enter this space, feel free to reach out. That's a 4,000 mile an hour account of insects and entocycles. Thank you very much.
Thank you, Kieran. That was fantastic. Thank you very much. Again, that was the first time I'd heard Entocycle present, so I really enjoyed that. It was really interesting to hear a little bit more about your background. That was really cool. And also a great stat that the UK was the first to enable insect protein in pet food. I didn't know that one, so again, I'll use that.
So, yeah, along with the rest of Europe, but it was a fun. We were actually, from a scientific and health and safety perspective, absolutely leading in this area.
That's really good to know. I will definitely use that one. And finally, I'm really glad to learn that Scotland is leading the way. That's really nice to hear, and hopefully we can continue to support you in your journey.
Absolutely. Fantastic. Thank you very much.
Thanks, Kieran. And we're moving on to our final presenter for today. And we've got Tanveer Khan, who's Head of Science at Intelligent Growth Solutions. And Tanveer is going to be talking to us around vertical farming technology. So let me stop sharing, Tanveer, and I'll let you share your screen. Oh, Tanveer, are you still with us?
Can you guys hear me?
Yes, I can hear you now.
All right, fantastic. Yeah, just a second. Right, I'll just put that on the presentation mode. All right, first of all, thank you very much for inviting me to this interesting discussion. All the talks, they have been really fantastic, and I just hope that I would add the last piece to further this interesting discussion and collaboration. Okay, so I'm going to talk about IGS. Now, we have been having very nice discussions and also collaboration with iBioIC as well as with the Scottish Enterprise. So just to give you a bit of an overview about IGS, we are a leading vertical farming infrastructure development company based in Edinburgh, Scotland. We have our Engineering Innovation Center in Inverkeithing and the Crop Research Center in Dundee. Okay, now just to give you an overview about the company, let's minimize this. IGS was founded by a farmer, Sir Henry Ackroyd, and an engineer, Dave Scott, who's the Chief Technology Officer of the IGS. We have so far raised around 81 million pounds in venture capital. We are well backed by, in some quite renowned venture capitals like S2G, Scottish Enterprise, Osprey, and DC Thomson. We have a large patent portfolio of 25 patents, mainly in the area of agriculture, mainly in the area of engineering, in heating, HVAC, and our lights. Okay. Now, so just to give you an overview about the IGS vertical farming technology, the concept that we came up with. So imagine if we have a field, a large field, and we all know that the land at the moment is shrinking, the total arable land, because of the climate change and also because of the human activity. So what a vertical farm represents is, think about that as a field, and then you can cut that entire field into the size of a snooker table, which is around 6 square meters of area, and then just stack them up. So IGS towers, unlike most of the vertical farm towers that you might have seen globally, they come in different heights. So we have the 9-meter high and the 12-meter high and the 6-meter, which is really big. That's equivalent to the area that you will find in an agriculture field. So around 320 to 420 square meter, depending on which height the customer chooses. So this is, then you take these layers and then put them in a box. Now this box, it could be anything. It could be a custom designed outer shell, like what we have here at our Crop Research Center. It could be a warehouse. It could be anything that you want. The main thing from IGS is these stacked layers, or what we call as growth trays with lights, and our HVAC system associated with that. And then we run our towers by controlling temperature, humidity, lights, and everything. So you give the perfect weather for a crop to grow. And people in this panel, they already know that vertical farm or greenhouse concept is pretty much growing crops in controlled environment. But how precise you can actually control this is what IGS differentiates with rest of the vertical farming companies. And I'm going to talk a bit more in further slides. So we have a cloud-based system which you can control with your tablet or phone. That means whichever light recipe you want your crop to grow in, if it is rocket or vanilla or mustard, you just feed the recipe, you tell the software what type of watering regime it requires, and then what is the temperature that it requires, and then you can control it from your phone, and actually you can monitor. So even if you are sitting anywhere on the globe and you have a farm elsewhere, maybe 500 miles away, you can still monitor your crop growth. So that's the kind of flexibility this system offers. This is just a drawing that we have. So overall footprint of this shell, or the cubicle, what we call, is around 41 square meter. Now this is for a 12-meter growth tower, and the max area that you have is 520. So if you go for 9-meter, then you'll have around 420 square meter area. And you see that you have an airlock entry, then you have the central heating, central handling area, and then you can put your growth towers. Now, each growth tower, it has 2 units. One is in the front and the other one is in the back. And this is around 6 meter into 6 meters. So these are like small square chambers that you have. So you can highly control your functionality in the system. Now, one interesting thing about IGS is that we are not the growers. Okay, so we grow crops only for research and development purposes, and this is to enable our customers. So when we give this functional unit to the customer, we top that up with our crop growth recipes. So the customers, they have some basic science to start with, and then they can just plug it and play, and then they can fine tune further in future. This is the company motto, that we don't even want to compete with the growers or the producers. Instead, we want to actually enable them. So this is another differentiating factor for IGS with other companies like Plenty or Aero Farms or Freight Farms. Okay. We have our engineering capabilities, agronomy, crop science, and data science. So the entire system, this is the backbone for that. and we have several research and customer-based project running across these disciplines. It's a very nice interaction between the groups to come up with novel ideas, and that's how we actually support and enable our customers through all the disciplines. A bit of background about the crop research. So we are based at Crop Research Centre in Dundee, actually right next to James Hutton Institute. For those who are based in Scotland, you might know. Otherwise, you can Google search. So this also enables our research, with the academic institute. What type of crops we grow? So we have a large variety of crops that we actually grow, depending on what the farmer wants. And unlike most of the vertical farming companies, we just don't focus only on leafy greens and herbs. Instead, our portfolio is quite diverse. It has we are able to grow even trees. We are growing radishes. We grow seed potatoes and flowers, basically to enable the agriculture throughout the globe. We can fine-tune our recipes to grow crops with different nutrient, as well as to get different taste for different types of crop, depending on fine-tuning our light and nutrient recipe. Extended shelf life, which is one most important thing here. So obviously, our crops, based on the recipes that we give, as well as further downstream treatment after the harvest, they can stay fresh for a long time. They are healthy and safe, so they are grown in highly controlled environment, no pesticides, no chemical treatment over there. Just want to tell you here that we do use chemical nutrients, but if our customers want to try something organic, they are more than free to do so, because this system provides the flexibility to try growing crops on whatever type of nutrient mix that you want to work on. Moving on, so this is just a bit of statistics for the IGS crop. So we have, for basil, per year, we get almost 20 harvests, which is 3 times more than the glass house or in a greenhouse, and 10 times more than the open field. We don't use any fossil fuels. We don't use any other chemicals in our system. That even applies even to our manufacturing. So we do care about the sustainability aspect when we design the tower, as well as when we run the tower. The electricity based on our system, so our towers, they are 3 times more efficient, or they actually run at a third of the electricity requirement compared to other vertical farm. Now, this is basically based on the system of light input that we use. So instead of using an AC system, we actually convert it into a DC. So all our LEDs, they run on that and the HVAC, and that actually reduces the power consumption for our system. Another important thing on the electricity part, that we can actually integrate with any kind of energy source. So it could be run on solar, it could be run on geothermal or whatever. There are systems in place, and our engineering team provides all this kind of support to plug our IGS towers to run into any kind of system that you want. In Dundee, we actually just are still using the grid-based system, but the statistics that you see here is based on the grid-based system, which still is much more efficient. We use 73% less water and 98% less water than the open field. This is an area which we are still working with some other sustainability projects with different institutes that I'm going to talk about in more. Just a reflection of the IGS crop portfolio. So when we say that we are able to grow crops, we are not just able to grow crops, but they are quite specific, so we can fine-tune their growth. So far, we have grown rose starter plants, and we have taken all the way up to the flowering. We have grown almost like 15 different varieties of roses, edible flowers, conifers. We have grown 7 different types of conifers and almost 10 different types of broadleaf species. They are 3 to 6x faster and 40x cheaper than the conventional system. We have grown seed potatoes, which is 2.5x faster. Just to differentiate, this is not the final potato. This is the seed potato that will be planted in the fields or in the polytunnel. This is a project that we ran with James Hutton Institute. We grow strawberry starter plants, chilies, dwarf tomatoes, as well as the starter plant. So it's quite broad. And through this, we are actually trying to enable farmers across the globe and to help them make profits on whatever they want to focus on. Now, one interesting aspect about IGS, we say that we don't compete with the growers, but at the same time, we facilitate the growers all across, and we don't also compete with other systems. So our motto is that we would like to have an integrated system whereby IGS is a part of it. So whatever can be grown in the vertical farm should be grown in the vertical farm, in integration with other systems like greenhouses or open field or forests, because we know that there is no single golden bullet to tackle the challenge of climate change and lack of arable land which is available for agriculture. And with this global insecurity which is going on, we need to focus on integration of the system instead of actually competing against the existing system. Here, what we actually check the box in terms of zero emissions. So if you see, IGS technology was cited by David Attenborough in his book A Life Over the Planet. And if you see, we can have a huge impact on reversing the habitat loss. I'll talk a bit more about what we are doing in that area. So no emissions, collapsing the food miles, because our motto is to establish these kind of units wherever there is a need. It could be in the city center, it could be close to the city on the outskirts, whereby we reduce the food mileage, okay? And we have significant water savings, 250:1. This is based on the analysis done by the KPMG. We have a much smaller footprint. We don't use any pesticides. Our produce in the tower, they doesn't have to be washed, and there is much less wastage due to the longer shelf life. And we don't use any hydrocarbons. So this is another important aspect. Based on this, we click several of the sustainability goals as set by the United Nations. Where we are globally, so we have deployment over 4 continents. These are the major ones. And if you see these brown spheres, they actually highlight where there is severe degradation of the land. Now, our IGS towers are here. So we are based in America, we are in Europe, in Asia Pacific, as well as in Australia. And we have the potential rollout in different other countries. Now, based on this, we basically cover the entire globe. You might find that we still do not have a footprint in Africa and Latin America, but this is as of now. As we move forward, we'll be expanding into those areas as well. A bit about the IGS research focus area, which might be very interesting to the panel over here. So we are thinking to take vertical farming beyond vertical farming. And when I say that, that means moving a bit beyond just growing herbs and leafy greens and focusing only on the yield parameters. So we have 7 different focus areas indicated on these 7 petals. Of course, our focus is the customer, but at the same time, we try to grow crops with nutritional enrichment, spiking vitamins or mineral contents. We have several projects going on in this area. We tend to grow high value crops, focus on food quality and safety. But the key thing which I would like to highlight in this panel today is our focus on the sustainability. So we have few projects going on water treatment. That means after a few cycles, whatever water that goes in the vertical farm, we can actually treat it with algae or other such biological agents to make it more palatable for future. We are focusing on shelf life and packaging. So we are looking at different materials by having collaborations with material research institutes across the globe. Basically moving away from the conventional plastic-based packaging material for our customer. Now, I have said that we are not producers ourselves, but when we sell our towers to the customer, we give them a full package and as well as training. So this is to enable even our customers to choose which works best and is good for the environment. We are expanding into the area of breeding and gene editing through academic collaborations, and our focus is also on bioconservation, which is enabling some endangered species to be grown in our towers and then replanted outside. So reforestation efforts are one of the prime importance for us. We have global network projects in all these areas because we know that we cannot do everything on our own, and that's why we rely on academic and industrial partnerships. We have few grants that have been approved, like Innovate UK and BBSRC, and through which we would aim to achieve these highly ambitious goals for IGS. One interesting thing from our side is that we have a IGS Global Research Network, and my colleague Chris Horn, he heads this area, whereby we establish partnerships. In UK, we have set up 2 towers, like our towers that I described earlier in Nottingham Trent University and Edinburgh University. They are in the phase of being set up. This is to enable academic research. And what IGS brings to the table, we install these towers. Part of the funding needs to be paid by the university or the institute, but they can do research in 75% of the space in our tower. 25% is reserved for the IGS research. And we do support the PhD and postdoc fellows, depending on the project in those institutes. Now, this is one way from our side to expand our research network portfolio and also to enable the academic research in UK as well as in other countries. And all these areas highlighted in green is where we have our global research network. The themes will be very much what I described in the previous slide. And that's it from my side. I am more than happy to take any questions if you might have. Thank you.
That was great. Thanks very much for that, Tanvir. And it was really great to learn a little bit more about how you set up a vertical farm. I had the pleasure of going up to your site in Invergowrie a few years ago now, but it was really impressive. So if anyone gets a chance, I would absolutely recommend it. And it was also really great to see how much water can be saved through vertical farming versus, growing it in a greenhouse or a field. And so thank you very much for that. So everyone, that brings us on to our Q&A session for today. And I see that we've got quite a number of questions. So if I could ask all of our speakers to unmute. And then we'll have a look and see what questions we've got for you all. So kick off with one for you, Craig Johnson, and that is, as someone who's allergic to corn, she was wondering whether or not you have done any toxicity or allergy testing on Abunda proteins.
So the product that we make uses exactly the same organism as corn, which is one of our strategies. So we've done equivalent studies. So it's really the same allergen as for corn. As I said earlier, we're B2B, so that would be with our customers in terms of the packaging, labeling, and also the any warnings.
Great, thanks very much, Craig. And next question I think is for you as well, and it's someone's wondering.
It's looking at the what's the titer of the process. So there's a range. It's quite a interesting fluid because of the high flow length, but between 10 and 30 grams per liter in terms of the titer for the production of mycoprotein.
Thanks, Craig. Next one's for you, Joe. And do you expect spirulina protein to be able to compete on price with soya proteins in the sausages?
Yes, we do. I think from the offset, my work as I mentioned, having that price point is key. There's no point developing particularly bulk novel proteins that aren't going to be able to compete on price with the likes of soy. So we've done a couple of things. Firstly, because our core product, the blue pigment, it is a high value product. We sequester a lot of the costs associated with producing the biomass and the spirulina, which are the bulk of the costs are associated with that high value product. And that means that I could focus with the proteins upon sort of minimizing the costs of manufacture. So from conversations with a lot of these food manufacturers that are going to potentially use the protein, they're probably willing to pay in the region of sort of anywhere from 5 to maybe up to 20 pounds a kilogram, depending on the protein. So we kind of know the ballpark figures that we need to operate in. But the point of having the functional ingredient is because it offers a bit more and it's used in smaller quantities, that gave us a little bit more scope. It will be a more expensive product, but the functionality is greater on that. So this is why having both products allows us to tap into the lower priced bulk protein market, and the functional ingredient allows us to operate at slightly higher costs of manufacture. But it's a good question that the price is always is the key thing when sort of designing a lot of these novel protein products.
Absolutely. Thanks very much for that, Joe, and hopefully that answered your question, George. Next, we've got a question for, and I think this one will be for yourself, Craig Sterling. And it's, does the cardboard packaging with the coating need to be cleaned prior to recycling?
Oh yeah, it'd be the same as anything else. You should still do that. Like when you rinse your bottles or anything, you could just do it a rinse. But yeah, you wouldn't want to have food stuff in there.
That's great, thanks. Yeah, just as you do.
Sometimes I feel like I've spent more time cleaning my recycling than my own dishes. But I don't know.
I think I'm the same, and then I never know what bin to put it in when I'm in the office.
Yeah.
So we've got another one for you as well, and Caroline was asking, is there an issue with regards to using shellfish waste for using for food packaging for those with allergens? So is anyone who's got a shellfish allergy, would there be any issue with using that as packaging?
No, the extraction process removes the allergen, which is a protein. So deproteinization is a big part of our process of separating the chitin from everything else that's there. So we can actually capture that protein separately and use it for therapeutics and different things like that, and for research. But it's removed first through the extraction process to chitin, and then it's removed even if there's anything left, it's polished out through the conversion from the deacetylation conversion from chitin to chitosan. So it's gone entirely. And then even further than that, it's what we use in the chitin that's then in formulation is so dilute and minuscule. I mean, you're talking about parts per trillion. It's absolutely undetectable and it's not there.
Yeah, that's really good to know. Thanks for that, Craig. That was a good question. So the next question I think is probably for all of you, and it's a really good one from Dana. And she was saying that Michelle Donnellan emphasised in her scale-up speech last week that the government is committed to make the UK a scale-up powerhouse. And I think this has been an issue for quite a long time, that people often move abroad. So what would the speakers need or require to ensure they're not moving abroad but to stay in the UK to manufacture? And I'll maybe come to Craig Johnson. I know that obviously you do have a site abroad. If you were to go back in time, what would have kept you here?
We can't manufacture in Scotland because there's no biorefinery. It really is as simple as that. Yeah. So our process has to be co-located with a biorefinery. So I know there are plans for our feasibility of a sugar beet, biorefinery. So if that existed, in Scotland, that could be an option. We also had some discussions with whiskey industry, but there's issues potentially of using our waste in whiskey for obvious reasons. So that's the reason we're not located in Scotland. In terms of the kind of piloting, there's no food grade pilot facilities, in Scotland, which is why we went. And at that time, there was none in England either. So that's why we went to bio-based Europe. So it's a kind of a ecosystem of scale-up facilities. So I think iBioC does a great job, and also looking at the kind of small scale. But we are quite unique because of our process, and we need to be integrated with a biorefinery. So that's the primary reason from my perspective.
That's really useful to understand, Craig, and to anyone from the government on the call. I hope you're taking notes as to what infrastructure we still need here in Scotland to anchor our companies here. I'll maybe come to yourself, Joe, as well. You know, in Scott Bio's perspective, what is keeping you manufacturing in Scotland?
I think this for us, sort of in the start of our scale-up journey. I think Central Belt Scotland in particular is I'd argue one of the best places for accessing expertise, facilities, and you know, talent pools. It's really an ideal location. In terms of growing microalgae, I think if you can grow it in Scotland, then you know the point we wanted to demonstrate is that our technology can be done anywhere in the world. And I think particularly when talking about food miles and sort of supply chain risks, we actually want to make a platform which can be, you know, we can license that technology or scale it out to anywhere. So if you've got, I'll use the obvious example, if you've got if you're Mars and you're making Smarties and you need however many tens of tons of blue colorant, then it makes sense to license the technology and have you potentially make the blue right on your doorstep, so you can, you know, you can alleviate any disruption to your supply chain. So that's the kind of the model that we're going for. But I mean, you know, for the start of our journey, we're going to be making blue in Scotland and kind of be based here for the foreseeable future. So it has everything we need to have for our business model at the moment, but there's nothing stopping it being replicated anywhere else.
Thanks very much, Joe, and that's great to hear you're going to be here for the foreseeable. Any of the other speakers want to come in on that one?
I could add a couple of points, which I think that those guys are really kind of nailed it already. But the two, one is like the UK and Scotland, particularly great at innovation funding. It's still dwarfs some other countries, especially like France or Holland, for example, especially on a per capita or per head person. The biggest issue in that is CapEx funding in innovation. So actually, you're seeing places like Finland who are already now switching their R&D to actually incorporate CapEx, which is a massive burden for especially the earlier stage companies. But as they're starting to transition, I think actually CapEx funding is fundamental. And then secondly, specifically for insects. So the legislation landscape in the UK is just behind. It is falling, but it's like we've got thrown an anchor overboard and we're trying to drag it slowly while everyone else has turned on the speed jet engines. And so just actually A, playing parity to the rest of Europe, or B, actually looking at other parts of the world which have best in class legislation, such as the US, such as Australia, etc. And again, we're not talking about GM here. We're not talking about we're just talking about just updating standard legislation.
Thanks very much for that, Kieran, and I absolutely agree with regards to CapEx. And you know, a lot of companies that we work with do face a lot of challenges around CapEx, particularly when they're trying to grow and get over that valley of death.
Yeah.
And agree as well, like, again, on the legislation front for insect protein. And I know many companies have challenges with that. So thank you for that. I think we'll move on to our next question. And Craig Sterling, I think this one might be for you as well. And it's when do you expect to be producing at scale?
Yep. So our first factory is actually opening in end of February, beginning of March in Glenrothes for extracting the chitin. So that's actually going to be the first biomaterial that's available. So the very first products, which is the chitin itself, the crystal chitin and the crystal chitosan, is available in March. The films we're actually manufacturing trials on right now. So we're just sorting out the final details on manufacturing. We've made a film, which is substantial. It's an amazing film. And we just have to figure out how to manufacture it. So translation there. So, you know, little things like drying speeds and drying times. So we're in the process of doing that now. The hope was that we'd have that in March. We're still hopeful that will happen, but we haven't sorted out the drying times yet. So it might be April or May, but we're working through that. The coatings are available essentially as soon as the factory is open as well, because those are just formulations. Those are going to be sent in dispersion and those are ready to go. So for those primary products, now the fibers and things like that, that's a longer term development. So that would be, you know, at least 2 years out probably for the fibers.
Thanks very much, Craig. And it's really exciting to hear that some things might be coming to fruition in March.
It is, yeah, a long time coming. So it's good to see it. It's exciting.
Absolutely. I've got a question here for Jeremy. Is Jeremy still with us?
Yep.
You still there? Sorry, Jeremy, I couldn't see you on my
There,
screen here.
yeah.
That's all. And that is when and with whose products can we find your sugar in the UK market? So people are obviously keen to sample your products. I'm certainly keen to sample your chocolate.
Yeah. Can't sell it yet in the UK. So if you've been around when we've been around at various events, you might have had the chance. It's a two-pronged strategy in the UK. One is actually to reformulate our ingredient to kind of sidestep that regulatory piece, and the other one is really ploughing through ahead with getting it through the UK Food Standards Agency. So it won't be until one of those things comes to fruition, unfortunately, but you can try the other ingredient. In fact, we have a shop on Etsy we set up just before Christmas, because we had lots of friends and family requests for products to try the pasta that's actually being served at the Cambridge colleges. So you can buy that online or through our website. So you can at least try one of our ingredients in the UK.
Well, great. That's good to know. I'll get myself on Etsy for that then. Thanks very much. We've got another one for you as well, just while you're on. So that is usually bloating is an issue with oligosaccharides. Can't say that word, sorry. Oligosaccharides. So how do you address that issue?
Yes, so it's actually one of the key reasons why the existing kind of sugar replacement technologies haven't kind of cut through the market. Things like inulin, you can only eat less than 10 grams a day, whereas our ingredient, tolerance up to 45 grams a day. And the reason for that, again, is it's the same as the functionality. It's a composition, it's a mixture, it's not one single thing. Your body's not great, so when it just gets bombarded with, or your digestive system with lots of one thing, when if you give it a mixture of oligosaccharides, soluble polysaccharides, and actually a bit of insoluble polysaccharide, it kind of mellows everything out. And that helps, and actually, so the composition helps with functionality, and also the composition, in fact, it's a mixture, helps with the tolerance.
Great, thanks very much, Jeremy. And we've got one last one for you, I think.
Right,
that is sorry, you've been put on the spot here.
Okay.
How much cheaper could your flour be than, say, milling wheat flour?
So we aim, you'd like to think we could have a premium given what we do over those incumbent ingredients, but ultimately it's kind of cost parity. It's very difficult to get any cheaper than those staples that are already out there at the moment. But we shall try. But I think it's going to be parity's the aim rather than kind of undercutting those staples.
That's great to understand. Thanks very much for that, Jeremy. I think that was your last question, so you can breathe easily now. And the next question is, so Tanvir, this could be one for you, and it's do any of the companies use renewable sources of energy for production or have plans to increase reliance on renewable energy?
Yeah, more than you can think of. So since we are a technology provider to different companies, most of our customers, they ask for this. Of course, you know that renewable energy is not available everywhere, right? So I'll highlight two things. One is the recent announcement that came from IGS for our joint venture with Refarm. So they are a waste-based energy source system based in Dubai. And they have that, they want to run the vertical farms over there in a circular fashion. So renewable source of energy. And so this is one. So we support that. We do have a VFAST project with Re-Energize, which is another company focusing on renewable sources of energy, and they have their, the high density hydro project. There are a few other companies that we deal with in Norway who are thinking to use wave-based renewable energy and even geothermal energy. So yes, I think as the awareness is increasing globally, our customers, they are becoming more and more aware. So they are choosing to go ahead with renewable sources of energy. We do, from our side, when we talk to the customer, we do emphasize on that because it will be cheaper. Solar is the easiest one for us. So in that regard, yeah, that's what we can do from our end. I think depending on the country, because our operations are global, so there has to be some support for companies who are venturing into this area, whereby they get more subsidy on the renewable energy sources to run vertical farms or even greenhouses. So that would be quite helpful.
Thanks for that, Tanvir. And does anyone else want to come in on if they're using renewable energy? Any of the other companies?
Just to mention, yeah, I think most companies, when you see things like even large companies doing life cycle assessments, you will see renewable energy being a key part into how they deliver those kind of greenhouse gas emission savings. And so I think that's stuff that even small companies are cottoning on to.
Yeah, absolutely. Thanks, Jeremy. Tanvir, the next question, I suppose it almost kind of follows on from that previous one. So question here around how a day's energy cost is going up and vertical farming is a lot of light and energy artificially, and that it may continue to go up further, it may be quite unpredictable. So do you think an economy of vertical farming will remain feasible?
Yep. Good question, first of all, because the economics of the vertical farm is the big challenge at the moment, because everybody has seen there are so many vertical farming companies who have gone bust. But the reason is not just the energy, it's other things associated with that, which we can discuss separately. But I'll just keep my focus on the energy. So yes, we do provide artificial light and energy. As I mentioned in my talk today, that we have a system, actually an IGS innovation. So our LEDs, they are running at much less power than rest of the LEDs that you see in the market. So that's one where we cut down the cost of electricity. The same is with our HVAC. So overall, we are 30% more efficient. The other thing what we do is when we develop our crop recipe, we have the recipe calculator. So whatever input we give for red, green, blue, and far-red light, it gives an energy factor. And depending on the growth cycle of the plant, we fine tune. So we have a stage gated pipeline whereby we go with 4 different stages and we get the recipe that's best for yield, quality, and energy. So this is second. The third thing that we emphasize is the ways of working. So whereby you have a grid-based system, okay? You need to run your vertical farm in a manner where the power cost is less. So for example, run your recipes at night because the plants need the dark period and the light period. So in day, you can have the dark period that will cut down your energy cost. So these are few things that we give as part of the tailored recipe to our customers. And since our customers are quite global, so we have to customize this solution for those. The next thing is the government policy, which I already mentioned, that it would be quite helpful in scaling up the economics. I think one key factor from any vertical farming company would be that they should move away from the question of can we grow this to can we profitably grow a particular crop. So we bring that profitability factor. We don't give our recipes to the customer unless they have been tested at a scaled up manner. That means at least half the tower is full with that, and with a completely different team that we have here in our company. So this is like a handover thing. So these are certain practices that we do. I think I am a very positive person, and I believe that there are researches going on globally to find cheaper sources of energy. So MIT did some research whereby they have developed a concrete capacitor. So they can store energy. So right now, energy generation is not the problem, it's the storage and transmittance. So these are the kind of inventions that are going to be quite helpful. And I think the speed at which they are happening at the moment, it has finally caught up. So in next 5 years, we will definitely be working much more economically in this kind of an industry. At the moment, the picture might seem gloomy, but I think it's going to improve. Last thing from my side is I'll just give example of electric cars. So 10 years ago, the person who gave the concept of EVs, everybody challenged him on, where the batteries are going to be or how they'll function. And now look at the adaptation. So this has become both from innovation and adaptation. And I think that's the same that's going to work for energy sector as well. So that's my answer.
Well, that was a
Right.
great, answer, and thanks very much for all that insight. That was fantastic, and I didn't know about that example from MIT either. So we've got a question here for yourself, Kieran, and that's on black soldier flies, and that's can BSF grow on any type of waste? Are there restrictions regarding the end of use of the product? And also, has anyone looked at the genetic modification of BSF to improve nutritional content? So a couple of ones for you there.
3 questions. So they can eat, biologically, they can eat almost anything. So we've done everything from like traditional feedstuffs through to food waste from supermarkets, reverse logistic wastes from fruit, vegetable, brewing, you name it, all the way through to chicken manure, pig manure, and to human waste. So that didn't happen in the UK, that happened internationally. As long as you get the blend right and the amount of insects right, they will eat it and consume it. Like that's what they do in nature. You know, literally, that's why there are certain phrases such as flies on, etc. That's one thing. So will they eat it? Of course they will. It just has to do it right. And again, that's where our machines come into play. Legislatively, absolute minefield. So depending on what you feed it, depends on which market it goes into. In the Europe, insects considered a farmed animal. External to Europe, they're not. So again, this is why we don't just focus on the UK and Europe, we focus globally. And then lastly, and again, that depends. So people are now looking at biofuels from the lipids from insects. People are looking at chitin extraction, similar to one of the other speakers here. There's a whole range of products, depending on what you feed them, that you can then post-process or bioprocess the insects themselves. If you're looking at just food and feed, it's a bit of a minefield, but there's that clear, straight legislation. I forgot what the last question part was, genetic modification. So there are multiple, the insect industry is quite a large landscape. The answer, yes, there is. It depends on different companies are looking at different parts of the value chain. You have one in Scotland who are looking at certain types of manipulation. I wouldn't say genetic modification, but manipulation of we have an in-house breeding program, because we believe that just by recycling every month, every 25 days, you have a new generation. And so you're able to really kind of stress test for speed, growth, production, just as you would traditionally in farming. So there's a range of different, the answer is yes. Again, speak at 1,000,000 miles an hour, say a lot of stuff, but ultimately, yes, yes, and yes to the questions.
Thanks very much for answering that, Kieran. That's great. Hopefully that answers your question, Liz. And I think we've got time for maybe one last question. It's quite a lengthy one. Craig Johnson, this is for you, from Ian Archer. And he's asking, do you know of other examples of innovation where different bioprocesses have been integrated to enable cost and sustainability gains?
Yeah, thanks for the question, Ian. Hope you're well. So in terms of the biorefineries that I've mentioned, that aren't in Scotland, there's quite a lot of integrated processes there operated by different companies. So that could be, for animal feed. It could be for creating, clean sugar, and then downstream products from that. We also look at other, or we've been asked to look at other projects, dairy waste. I know of a French company that's looking at, tomato waste. And one of the key things is co-location, because for a lot of these things, transportation costs can be significant. Now, here in Scotland, we've got some great companies like Celtic Renewables, myalgae, more on the kind of bio, fuels, bioproducts, type thing, and they're looking at whiskey waste. And again, the kind of limitations on these type of technologies are what's the sales price, what's the concentration of material that you're using, and how big should your factory be. So really, it's commercial assessment. And I've seen many of these. I've been asked to be involved, in several from an enough perspective. So I would say that the key limitation would be the techno-commercial side, and also how much the consumer, is willing to pay for the particular product, and whether you can differentiate to have something that's maybe more a pharmaceutical grade rather than a more mass commodity type product. It's a very good question, Ian. But we're starting to see a lot more of these of these types of integration with more than one companies. And you may have a large company, in our case Cargo, but other companies where they're looking at having a kind of a hotel for fermentation, and you have other companies based around about that.
Oh, Jeremy, you put your hand up.
Yeah, could I just to follow on, and it's just that interesting about biorefineries versus petrochemical refineries, is that I think as Craig pointed out, that the biorefinery has a potential to produce specialty chemicals, fuels, materials, and food, whereas a traditional petrochemical refinery doesn't. And so I think we're starting to see actually at the minute we're getting very, like, through funding calls, focus on materials, focus on things, but not actually integrating those two things. And we might end up with biorefineries that do one or the other when actually they could do both, and that will help out in actually, you know, reducing the costs across the board. So not to lose sight, just because a petrochem refinery doesn't make food doesn't mean a biorefinery can't.
That's a really good point, Jeremy. And thank you very much for your answer as well, Craig. I think that was really
Yeah, and just on Jeremy's point, so before we rebranded to enough, as some of the companies have rebranded, we were 3F, and the 3F stands for food, fuel, and feed, and that kind of triangle, is very important for a broad range of reasons.
Absolutely. I think that's all we've got time for today. I know there was a couple of more questions in the Q&A box, but we'll answer those maybe offline and bring today's session to a close. So I would like to thank everyone who has joined our session today. And I'd also like to say a huge thank you to all of our speakers. I thought they were fantastic talks, and we had some really good Q&A there as well. And thank you as well for all the listeners, because I know it's been quite a long session this morning, so thanks for staying on the call. I hope everyone has a great rest of the day, and I will stop our session now. Thank you very much.
Thank you.
Thank you.
Thank you.